Question 1. The force exerted by the jet on fixed plate in figure below is equal to. In this figure, a plate is given and the strike of a jet, so area A, velocity V and angle theta. So option A is AV square sin theta divided by G. Option B, rho AV square into sin theta divided by G. Option C, rho AV square cos theta divided by G. Option D, AV square tan theta, and option E is AV square cos theta divided by G. So correct answer is B. The force exerted by the jet on a fixed plate, according as on this figure, it will be rho AV square sin theta divided by G. Question number 2. If a jet of water of area A strike with velocity capital V a series of plates mounted on a wheel of mean diameter capital D rotating at capital N RPM, then force exerted by equal to option A, rho AV square divided by G. Option B, rho AV divided by G in the small bracket V minus pi D N divided by 60, and option C, rho A upon G into pi D N divided by 60, and option D, rho A in the small bracket V minus pi D N by 60, and option E is A upon G in the small bracket V minus pi D N by 60. So correct answer is a B. It will be rho AV divided by G in the small bracket V minus pi D N by 60. Question number 3. A jet of water enters and leaves a fixed curved vane of inlet and outlet angles are alpha and beta. Tangentially, the force of the jet along normal to the vane is option A, rho AV square divided by G in the small bracket cos alpha plus cos beta. Option B, rho AV square divided by G in the small bracket cos alpha minus cos beta. Option C is a rho AV square divided by G in the small bracket sin alpha plus sin beta plus option D is rho AV square divided by G in the small bracket sin alpha minus sin beta, and option E is rho AV square divided by G in the small bracket tan alpha minus tan beta. Correct answer is B. It will be rho AV square divided by G in the small bracket cos alpha minus cos beta. Question number 4. A jet of water enters and leaves a moving curved vane. The velocity of whirl at inlet and outlet being V omega 1 and V omega 2. The force of the jet in the direction of motion of the vane is option A, rho AV divided by G in the small bracket V omega 1 minus V omega 2. Option B, rho AV divided by G in the small bracket V omega 1 plus V omega 2. Option C, rho AV square divided by G in the small bracket V omega 1 minus V omega 2, and option D, rho AV square divided by G in the small bracket V omega 1 plus V omega 2, and option E is rho upon G in the small bracket V square omega 1 minus V square omega, it's V square omega 1 minus V square omega 2. Okay, so correct answer is A. It will be rho AV divided by G in the small bracket V omega 1 minus V omega 2. Question number 5. The specific speed of a pump is defined as the speed of a unit. Option A, such a size that it delivers unit discharge at unit head. Option B, of such a size that it delivers unit discharge at unit power. And option C, of such size that it requires unit power per unit head. And option D, of such a size that it produces unit horsepower with unit head. And option E is none of the above. Correct answer is A. The specific speed of a pump is defined as the speed of a unit of such a size that it delivers unit discharge at unit head. Question number 6. Reciprocating pumps are no more to be seen in industrial application in comparison to centrifugal pumps because of option A, high initial and maintenance cost, option B, lower discharge, option C, lower speed of operation, and option D is a necessity of air vessel, and option E is all of the above. So correct answer is A, high initial and maintenance cost. Question number 7. In a centrifugal pump casing, the flow of water leaving the impeller is option A, rectilinear flow, option B, radial flow, option C, free vortex motion, option D is a forced vortex, option E is none of the above. Correct answer C, it will be free vortex motion. Question number 8. Head developed by a centrifugal pump depends on option A, impeller diameter, option B, speed, option C, fluid density, option D is a type of casing, and option E is A and B above. So correct answer is E, it will be A and B above, means impeller diameter and the speed. Question number 9. For starting an axial flow pump, its delivery valve should be option A, close, option B, open, option C is depend on starting condition and flow desired, option D is could be either open or closed, and option E is a partially open and partially closed. Correct answer is B, it will be open. Question number 10. If capital D is the diameter of the impeller at inlet and omega is or W is the width of impeller at inlet and Vf is the velocity of flow at inlet, then discharge through a centrifugal pump is equal to option A, pi d Vf, option B, dVf W, and option C, pi dVf W, and option D is a pi dW, and option E is pi d square Wf. Correct answer is a C, it will be pi dV subscript Fw will be the discharge through the centrifugal pump. Question number 11. The efficiency of a centrifugal pump is maximum when its blades are option A, straight, option B, bent forward, and option C, bent backward, option D, bent forward first and then backward, option E, bent backward and first and then forwarded. So correct answer is a C, it will be bent backward. Question number 12. In a centrifugal pump casing, the flow of water leaving the option A, radial, option B is also radial. Okay, option C is a centrifugal, option D is a rectilinear, and option E is vortex. So correct answer is E, it will be vortex. Question number 13. A centrifugal pump has following specification. Speed is 1000 rpm, flow is 1200 lpm, and head is 20 meter and power is 5 horsepower. If the speed is increased to 1500 rpm, new flow will be option A 1800 lpm, option B 2700 lpm, option C is 1200 lpm, option D 4500 lpm, and option E is none of the above. So correct answer is A, it will be 1800 lpm. Question number 14. In above example, new horsepower will be option A 5 HP, option B 7.5 HP, option C 11.25 HP, option D is 16.9 HP, option E is 22.5 HP. So the correct answer is D, it will be 16.9 HP. Question number 15. Centrifugal pump is started with its delivery valve. Option A kept fully closed, option B kept fully open, option C irrespective of any position, option D is kept 50% open, and option E is none of the above. Correct answer is A, it will be kept fully closed. Question number 16. Axial flow pump is started with its delivery valve. Option A kept fully closed, option B kept fully open, option C irrespectively of any position, and option D is kept 50% open, and option E is none of the above. Correct answer is B, it will be kept fully open. Question number 17. When a piping system is made up primarily of vertical lift and very little pipe friction, the pump characteristic should be option A horizontal, option B nearly horizontal, option C is a steep, option D first rise and then fall, and option E is none of the above. Correct answer is C, it should be steep. Question number 18. 1 horsepower is equal to option A 102 watts, option B 75 watts, option C 550 watts, and option D 735 watts, and option E 33,000 watts. Correct answer is D, it will be 735 watts. Question number 19. Multi-stage centrifugal pumps are used to obtain option A high discharge, option B high head, option C pumping of viscous fluid, option D high head and high discharge, option E high efficiency. So correct answer is B, it will be high head. Question number 20. If capital H is manometer height in meters, capital Q the discharge in meter cube per second, and neta the overall efficiency of the pump, and rho is the density of the fluid, then power is drive centrifugal pump is equal to option A rho QH divided by 75 neta, option B rho QH neta divided by 75, option C QH neta divided by 75, option D QH divided by 75 neta, option E 75 rho QH divided by neta. Correct answer is A, it will be rho QH divided by 75 neta. Question number 21. When a piping system is made up primarily of fabrication head and very little of vertical lift, then pump characteristic should be option A. Horizontal, option B is nearly horizontal, option C is steep, option D is first rise and then fall, and option E is none of the above. Correct answer is B, it will be nearly horizontal. Question number 22. In a single casing multi-stage pump running at constant speed, the capacity rating is to be slightly lowered. It can be done by option A, designing new impeller, option B, trimming the impeller size to the required size by matching, and option C is not possible. Option D is some other alteration in the impeller, and option E is none of the above. Correct answer is B, it's a trimming to be impeller size to the required size by matching. Question number 23. Power required to drive a centrifugal pump is proportional to option A is speed n, option B is n square, option C is n cube, option D is n power 4, option E is 1 upon n square. Correct answer is C, it will be n cube. Question number 24. The percentage slip for a reciprocating pump is defined as the percentage of option A, actual discharge divided by theoretical discharge, option B, actual speed divided by theoretical speed, option C is swept volume divided by cylinder volume, option D is theoretical discharge minus actual discharge divided by theoretical discharge, option E is actual discharge minus theoretical discharge divided by actual discharge. Correct answer is D, it will be theoretical discharge minus actual discharge divided by theoretical discharge. Question number 25. If a pump is handling water, is discharging a certain flow capital Q at a constant total dynamic head requiring a definite bhp, the same pump when handling a liquid of a specific gravity 0.75 and velocity nearly same as of water would discharge, option A, same quantity of liquid, option B, 0.75 Q, option C, Q divided by 0.75, option D, 1.5 Q, option C is none of the above. Correct answer is A, it will be same quantity of liquid. Question number 26. The horsepower required in above case will be option A same, option B is 0.75 bhp, option C is bhp divided by 0.75, option D 1.5 bhp, option E is none of the above. Correct answer is B, it will be 0.75 bhp. Question number 27. Low specific speed of a pump implies it is option A centrifugal pump, option B mixed flow pump, option C is axial flow pump, option D any one of the above, and option E is none of the above. Correct answer is A, it will be centrifugal pump. Question number 28. Pick up the wrong statement about overall efficiency of a centrifugal pump. It is proportional to option A discharge, option B is head, option C is bhp, option D 1 upon bhp, option E is discharge and head. Correct answer is a C, it will be bhp. Question number 29. Figure below show the curves between head H and the flow capital Q for the centrifugal pump impeller with different impeller van exist angle. You can see the graph between H and Q, and there is a B, C, 3 curves for a van For a when exit angle is a 90 degree, follow curve will be holds. Option A curve A, option B curve B, option C curve C, option D is all of the above, and option E is none of the above. Correct answer is B. It will be curve B. It means this curve will be holded. Question number 30. For forward inclined when, it's that the when having exit angle greater than 90 degree, following curve hold good reference figure of the above. Option A curve A, option B curve B, option C curve C, option D is all of the above, option E is none of the above. So correct answer is C. It will be curve C. It means this curve. Question number 31. Delivery head of a centrifugal pump is proportional to option A n speed n, option B n square, option C is n cube, option D 1 upon n square, option E is 1 upon n cube. Correct answer is B. It will be n square. Question number 32. Discharge of a centrifugal pump is proportional to A impeller diameter capital D and B is D square. Correct answer is okay. Discharge of a centrifugal pump is proportional to, there is a option A is impeller diameter D, and option B is D square, option C is D cube, option D is 1 upon D cube, and option E is D square. So correct answer is B. It will be D square. Okay. Question number 33. Power required to drive a centrifugal pump is proportional to option A impeller diameter D, option B D square, option C is D cube, option D power D4, option E is power D6. Option E is D power 6. So correct answer is D. It will be D power 4. Question number 34. For backward inclined when, it's that when exit angle less than 90 degree, following curve holds the good figure below. The figure between H and Q, curve A, B, C, D, and option A curve A, option B curve B, option C is curve C, and option D is all of the above, option E is none of the above. Correct answer is A. It means curve A. It means for the backward inclined when exit angle is less than 90 degree, curve A will be hold good. Question number 35. The optimum value of when exit angle for a centrifugal pump impeller is option A 10 to 15 degree, option B 20 to 25 degree, option C is 30 to 40 degree, option D is 50 to 60 degree, option E is 80 to 90 degree. Correct answer is B. It will be 20 to 25 degree. Question number 36. In a centrifugal pump, the liquid enters the pump. Option A at the top, option B at the bottom, option C is at the center, option D is from side, option E is none of the above. Correct answer is C. It will be entered in at the center. Question number 37. For small discharge at a high pressure, following pump is preferred. Correct answer is centrifugal, option B is axial flow, option C is mixed flow, option D is propeller, option E is reciprocating. So correct answer is E. For small discharge at high pressure following pump, it will be reciprocating pump. Question number 38. In centrifugal pump, maximum efficiency is obtained when the blades are option A straight, option B is bent forward, option C bent backward, option D is radial, option E is given airfoil section. So correct answer is C. It's work in centrifugal pump, maximum efficiency is obtained when the blades are bent backward. Question number 39. Motion of a liquid in a volute casing of a centrifugal pump is in is an example of. Option A is a rotational flow, option B is a radial flow, option C is a forced spiral vortex flow, option D is a forced cylindrical vortex flow, option E is a spiral vortex flow. So the correct answer is E. It will be motion of a liquid in a volute casing of centrifugal pump is an example of spiral vortex flow. Question number 40. For very high discharge at low pressure, such as for flood control and irrigation application, following type of pump is preferred. Option A is a centrifugal, option B is axial flow, option C is reciprocating, option D is a mixed flow, option E is none of the above. Correct answer is B, axial flow pump used for irrigation or the flood control. Question number 41. Medium specific speed of a pump implies it is. Option A centrifugal pump, option B mixed flow pump, option C is axial flow pump, option D is any one of the above, option E is none of the above. Correct answer is B, mixed flow pump. Medium specific speed of pump is implied is a mixed flow pump. Okay. Question number 42. High specific speed of a pump implies it is. Option A centrifugal pump, option B mixed flow pump, option C is axial flow pump, option D is any one of the above, and option E is none of the above. Correct answer is a C. It will be axial flow pump. For high specific speed, the pump implies at axial flow pump. Okay. Question number 43. Indicator diagram of a reciprocating pump is a graph between option A flow with swept volume, option B pressure and cylinder with swept volume, option C flow with speed, option D pressure with speed, option E swept volume and with the speed. So correct answer is B. It will be graph will be pressure between the pressure in the cylinder with the swept volume. Okay. Question number 44. Low specific speed of turbine implies it is. Low specific speed of turbine implies it is. Option A. Option A is a propeller turbine, option B is Francis turbine, option C is impulse turbine, option D is any one of the above, and option E is none of the above. Correct answer is C. It will be impulse turbine. Question number 45. Any change in load is adjusted by adjusting following parameters on turbine. Option A net head, option B absolute velocity, option C is a blade velocity, option D is flow, option E is relative velocity of flow at inlet. So correct answer is a D. It will be flow. In any change in load is adjusted by adjusting flowing parameter, it will be flow. Question number 46. Runaway speed of a hydraulic turbine is. Runaway speed of a hydraulic turbine is. Option A full load speed, option B the speed at which the turbine runner will be damaged, option C the speed if the turbine runner is allowed to revolve freely without load and with the wicket gates wide open, and option D is the speed corresponding to maximum overload permissible, and option E is none of the above. Correct answer is C. Runaway speed of hydraulic turbine is the speed if the turbine runner is allowed to revolve freely without load and with the wicket gates wide open. Okay. Question number 47. The maximum number of jets generally employed in impulse turbine without jet interference is. Option A 4, option B 6, option C is 8, option D is 12, option E is 16. Correct answer is B. It will be 6. The maximum number of jet generally employed in an impulse turbine without jet interference, it will be 6. Question number 48. Medium specific speed of turbine implies it is option A propeller turbine, option B Francis turbine, option C is impulse turbine, option D is any one of the above, and option E is none of the above. Correct answer is B, it will be Francis turbine. Question number 49. High specific speed of turbine implies it is option A propeller turbine, option B is a Francis turbine, option C is impulse turbine, option D any one of the above, option E is none of the above. Correct answer is A, it will be propeller turbine. Question number 50. The specific speed of a turbine is defined as the speed of a unit, option A, of such a size that it delivers unit discharge at unit head, option B such size that it delivers unit discharge at unit power, option C of such a size that it requires unit power per unit head, option D a such size that it produces unit horsepower with unit head, and option E is none of the above. Correct answer is D. The specific speed of a turbine is defined as the speed of a unit of such a size that it produces unit horsepower with unit head. Okay. Question number 51. Pick up the wrong statement about centrifugal pump. Option A discharge is proportional to diameter, option B head is proportional to speed square, option C head is proportional to diameter square, option D is power is proportional to speed cube, option E is none of the above is wrong. So correct answer is A, discharge is proportional to diameter. Pick up the wrong statement, so that one is the wrong statement. Question number 52. Specific speed of pump is indicated as option A n under root q divided by h power 3 by 4, option B n under root p divided by h power 5 by 4, option C n under root capital Q divided by h power 2 by 3, option D n under root p divided by h power 3 by 2, and option E is a n under root cube divided by h power 5 by 4. So correct answer is A, specific speed of pump is indicated n under root cube divided by h power 3 by 4. Question number 53. For identical pump operation, following ratio is a constant. Option A discharge per rpm, option B discharge per head, option C discharge per impeller diameter, option D is a head per rpm, option E impeller diameter per rpm. So correct answer is A, it will be discharge per rpm. Question number 54. Figure below show the relationship between power P and discharge Q for the different when exit angles of a centrifugal pump. Curve A holds good for. Question is curve A. This curve good for option A when exit angle is 90 degree, option B when exit angle of less than 90 degree, option C when exit angle more than 90 degree, option D any when exit angle, and option E is none of the above. Correct answer is B. Curve A is a hold for when exit angle of less than 90 degree. Question number 55. Curve B hold good for, according to this graph, this curve is belong for what? Option A is when exit angle is 90 degree, option B When exit angle of less than 90 degree, option C. When exit angle is more than 90 degree, option D is any when exit angle, and option is none of the above. Correct answer is A. Curve B is good for when exit angle of 90 degree. Question number 56. Curve C holds good for what? Curve C, this one is good for option A, when exit angle 90 degree, option B, when exit angle of less than 90 degree, option C, when exit angle more than 90 degree, option D is any when exit angle, and option E is none of the above. Correct answer is C, when exit angle more than 90 degree. Question number 57. A turbine pump is basically a centrifugal pump equipped additionally with option A, adjustable blades, option B, backward curved blades, option C, van diffusion casing, and option D, inlet guide blades, and option E is a totally submerged operation facility. So correct answer is C. A turbine pump is basically a centrifugal pump equipped additionally with vent diffusion casing. Okay, that is the correct answer. Question number 58. The action of a centrifugal pump is as that of a option A, reaction turbine, option B, impulse turbine, option C, reversed reaction turbine, option D is hydraulic ram, option E is none of the above. Correct answer is C, it will be reversed reaction turbine. Question number 59. In a mixed flow centrifugal pump, option A, two fluids are mixed up at section, option B, two fluids are pumped separately and then both mixed up at delivery, option C, two impellers, radial and axial type of employed, option D, option D is a flow through the impeller is a combination of radial and axial flows, and option E is such pumps do not exit. So correct answer is D. In mixed flow centrifugal pump, flow through the impeller is a combination of radial and axial flow. Okay. Question number 60. If small h and v is the stand for head and velocity, and suffix small s and d and f for the respectively suction, delivery and friction. Okay, the monometric head of a centrifugal pump is equal to option A, hs plus hd, option B, hs plus hd plus hf, and option C is hs plus hd plus hf plus vs square divided by 2g, option D, hs plus hd plus hf plus vd square divided by 2g, and option E is hs plus hd plus hf plus vs square divided by 2g plus vd square divided by 2g. So correct answer is B, it will be hs plus hd plus hf will be what? The delivery and friction of the monometric head of centrifugal pump. Okay. Question number 61. Question 61. To avoid cavitation in centrifugal pumps, option A, suction pressure should be low, option B, delivery pressure should be low, option C, suction pressure should be high, option D, delivery pressure should be high, option E, both suction and delivery pressure should be high. Correct answer is C, it will be suction pressure should be high to avoid the cavitation in the centrifugal pump. Question number 62. The work requirement of a centrifugal pump with increases in acceleration head. Option A increase, option B decrease, option C remain same, option D may increase or decrease depending upon the head developed, and option E is unpredictable. So correct answer is C. The work requirement of a reciprocating pump with increase in acceleration head is remain same. Question number 63. A double acting reciprocating pump compared to single acting pump will have nearly option A double efficiency, option B is double head, option C double flow, option D is double weight, option E is a 4-time power consumption. So correct answer is C, it will be double flow. Question number 64. For pumping various oil, which pump will be used? Option A centrifugal pump, option B reciprocating pump, option C is a turbine pump, option D is a screw pump, option E is a fuel pump as used in a diesel engine. So correct answer is a D, it will be screw pump is good for pumping the oil. Okay, question number 65. When a centrifugal pump is started, there will be no flow of water until the pressure rise in the impeller is large enough to overcome the option A static head, option B total head, option C monometric head, option D is a friction head, option E is all of the above. Correct answer is C, it will be monometric head. It means when a centrifugal pump is started, there will be no flow of the water until the pressure rise in the impeller is large enough to overcome the manometric head. Question number 66. Overall efficiency of a centrifugal pump is equal to option A volumetric efficiency neta into monometric efficiency neta into mechanical efficiency neta, and option B volumetric efficiency divided by monometric efficiency into mechanical efficiency, option C monometric efficiency divided by volumetric efficiency and multiply is mechanical efficiency, option D is mechanical efficiency divided by monometric efficiency into volumetric efficiency, option E is mechanical efficiency divided by volumetric efficiency into multiply to the monometric efficiency neta. So the correct answer is A. It means overall efficiency of a centrifugal pump is equal to the volumetric efficiency into monometric efficiency into mechanical efficiency. Okay, question number 67. Casting of a centrifugal pump is designed so as to minimize option A friction losses, and option B is cavitation, option C is static head, option D is loss of kinetic energy, and option E is a starting time. Correct answer is D, it will be loss of kinetic energy. Question number 68. The ratio of actual measured head divided by head imparted to fluid by impeller for a centrifugal pump is known as option A mechanical efficiency, option B volumetric efficiency, option C is monometric efficiency, option D is overall efficiency, option E is impeller efficiency. Correct answer A, it will be mechanical efficiency. It means the ratio of actual measured head divided by head imparted to the fluid by impeller, so it's called mechanical efficiency. Question number 69. If P is the power developed by a turbine under a head of water capital H, then unit power developed by the turbine is option A, P upon H, option B, P upon under root H, option C, P upon H power 3, it's 3 by 2, and option D, P divided by H square, and option E is P divided by H power 5 by 2. Correct answer is a C. It means P divided by H power 3 by 2. Question number 70. The unit speed of the turbine runner is option A, N by H, option B, N divided by under root H, option C, N divided by H power 3 by 2, option D, N divided by H square, and option E is N divided by N divided by H power 5 by 2. Correct answer will be B. It will be N divided by under root H. Question number 71. The unit discharge through a turbine is option A, Q by H, option B, Q by under root H, option C, Q by H power 3 by 2, option D, Q by H square, option E is Q by H power 5 by 2. Correct answer is a B. The unit discharge through a turbine is capital Q divided by under root H. Question number 72. The speed of a turbine and discharge through turbine are proportional to option A, head H, option B, under root H, option C, H square, option D is H power 3 by 2, option E, H power 5 by 2. Correct answer is B. It will be under root H. Question number 73. Specific speed of a turbine depends upon option A, speed, power and discharge, option B, discharge and power, option C, speed and head, option D, speed, discharge and head, and option E is speed, power and head. So correct answer is E. It will be specific speed of turbine depend upon speed, power and head. Question number 74. The specific speed of a turbine is the speed of such a turbine identical with a given turbine, which means option A, develops unit power under unit head, option B, develops unit power under unit discharge, option C, develop unit power under unit head, option D, develop unit speed under unit head, and option E is a delivers. All are develops, now is a delivers unit discharge under unit head. So correct answer is A. It means the specific speed of a turbine is the speed of such a turbine identical with a given turbine which develops unit power under unit head. Question number 75. Specific speed of turbine is indicated as option A, N under root Q divided by H power 3 by 4, option B, N under root P divided by H power 5 by 4, option C, N under root Q divided by H power 2 by 3, option D, N under root P divided by H power 3 by 2, option E is N under root P divided by H power 3 by 4. Correct answer is B. It will be N under root P divided by H power 5 by 4. Question number 76. An impulse turbine, option A, operates submerged, option B, requires draft tube, option C is a most suitable for low head applications, and option D is operates by initial complete conversion to kinetic energy, and option E is not exposed to atmosphere. So correct answer is D. It means an impulse turbine operates by initial complete conversion to kinetic energy. Question number 77. A Pelton wheel is option A axial flow impulse turbine, option B radial flow impulse turbine, option C is inward flow impulse turbine, option D is outward flow impulse turbine, and option E is mixed flow impulse turbine. So correct answer is A. It's a Pelton wheel is a axial flow impulse turbine. Okay. Question number 78. Pelton wheels are used for minimum of following heads. Pelton wheels are used for minimum of following heads. Option A 20 meter, option B 100 meter, option C is 125 meters, option D is 180 meter or the above, and option E is none of the above. Correct answer is D. It will be used for 180 meter or the above. Question number 79. The ratio of width of bucket for a Pelton wheel to the diameter of the jet is the order of option A is 2, option B is 3, option C is 4, option D is 5, option E is 6. So correct answer is D. It will be 5. Question number 80. The ratio of depth of bucket for a Pelton wheel to the diameter of jet is the order of option A is 1, option B is 1.2, option C is 1.5, option D is 1.8, and option E is 2. So correct answer is B. It will be 1.5. Question number 81. If capital D is the diameter of Pelton wheel and small d is the diameter of the jet, then number of buckets on the periphery of Pelton wheel is equal to option A capital D divided by 2D, option B capital D divided by 2D plus 10, option C capital D divided by 2D plus 15, option D capital D divided by 2D plus 20, option E is capital D divided by 2D plus 25. So correct answer is C. It will be capital D divided by 2D plus 15. Question number 82. The maximum efficiency of a Pelton wheel working under a constant head and discharge with the increases in power, option A increases, option B is decreases, option C is remain unaffected, option D is initially increased and then decrease, and option E is initially decrease and then increase. So correct answer is A. It will be increase. It means the maximum efficiency of Pelton wheel working under a constant head and discharge with the increase in power will be increases. Question number 83. Impulse turbine is used for option A low head, option B high head, option C medium head, option D high flow, option E high flow and high head. Correct answer is B. It will use for impulse turbine is used for high head. Question number 84. For maximum efficiency, the speed of a Pelton wheel as compared to the speed of the water jet is option A is the same, option B is half, option C is thrice, option D is 4 times, and option E is 1/4. Correct answer is B. It will be half. It means for maximum efficiency, the speed of the Pelton wheel as compared to the speed of the water jet will be half. Question number 85. If alpha is the angle of the blade tip at the outlet, then maximum hydraulic efficiency of an impulse turbine is option A 1 plus cos alpha divided by 2, option B 1 minus cos alpha divided by 2, option C 1 minus sin alpha divided by 2, option D 1 plus sin alpha divided by 2, option E 1 minus tan alpha divided by 2. Correct answer is A. It will be 1 plus cos alpha divided by 2. Question number 86. In reaction turbine, option A, kinetic energy is appreciable. Kinetic energy is appreciable as the fluid leaves the runner and enters a draft tube. Option B, the vanes are partially filled. Option C, total energy of the fluid is converted to kinetic energy in the runner. Option D, it is exposed to the atmosphere, and option E is it is not exposed to the atmosphere. So correct answer is E. It means it is not exposed to the atmosphere. In the reaction turbine, it is not exposed to the atmosphere. Question number 87. If alpha is the angle subtended, by two adjacent buckets in a Pelton wheel, then the number of buckets is equal to option A 40 divided by alpha, option B 180 divided by alpha, option C 270 by alpha, option D is 360 divided by alpha, and option E is any value between 180 divided by alpha to 360 divided by alpha. So correct answer is D. It will be 360 divided by alpha. Question number 88. In reaction turbine, draft tube is used, option A, to transport water downstream without eddies, option B, to convert the kinetic energy to flow energy by gradual is expansion of flow cross section, option C is for safety of the turbine, option D is to increase the flow rate, option E is none of the above. Correct answer is B. In reaction turbine, the draft tube is used to convert the kinetic energy to flow energy by a gradual expansion of the flow cross section. Question number 89. Guide angle as per the airfoil theory of Kaplan turbine blade design is defined as the angle between option A lift and resultant force, option B drag and resultant force, option C lift and longitudinal force, option D lift and drag, option E resultant force and the tangential force. Correct answer is A. It will be lift and the resultant force. Question number 90. Francis turbine is best suited for option A medium head application for 24 to 180 meter, option B low head installation up to 30 meter, option C high head installation above 180 meters, and option D all type of the heads, and option E is none of the above. Correct answer is A. Francis turbine is best suited for medium head application for 20 meter to 180 meters. Question number 91. Figure below show the part load performance curves of the various turbines. Okay, for curve A is a use for, so you can see in the graph the neta, between neta and the load percentage. So the part load performance curves, option, okay, the question is curve A is for what? Option A Kaplan, option B is Pelton wheel, option C is a Francis low specific speed, option D is a Francis high specific speed, and option is a mixed propeller. So correct answer is A. It means this curve, this is the curve A, and it used for the Kaplan turbine. Question number 92. Curve B is for what? You can see this is the curve B, and curve B is for option A is Kaplan, option B is for Pelton wheel, option C is Francis low specific speed, option D is Francis high specific speed, and option E is a fixed propeller. So correct answer is B. It used for the Pelton wheel. Curve B is used for the Pelton wheel. Question number 93. Curve C used for option A Kaplan, option B Pelton, option C Francis low specific speed, option D Francis high specific speed, and option E is a fixed propeller. Correct answer is C. It used for the Francis low specific speed. It means you can see the curve C. This curve is used for Francis low specific speed. Now for the curve D. This curve D for what? The correct answer is D. It is used for Francis high specific speed. This one is the curve D, and curve D is used for Francis high specific speed. Question number 95 is asking for the curve E. So you can see this last curve E is used for what? His correct answer is E. It's for the fixed propeller. Okay. Now question number 96 is different. Is a propeller turbine. Question number 96 is a propeller turbine is best suited for option A medium head application from 20 to 180 meters, option B low head installation up to 30 meters, and option C is a high head installation above 180 meters, and option D is all type of the heads, and option E is none of the above. Correct answer is B. It's a propeller turbine is best suited for the low head installation up to 30 meters. Question number 97. Speed ratio of a Pelton turbine is defined as option A actual speed divided by theoretical speed, option B pi into runner diameter into RPM divided by 60 into under root of 2g into head of turbine, and option C is 60 into under root of 2g into head on turbine divided by pi into runner dia into RPM, and option D is the speed of the runner divided by velocity of flow in the penstock, and option E is the actual speed divided by is a synchronous speed. Okay, so correct answer is a B. Speed ratio of a Pelton turbine is defined as the pi into runner dia into RPM divided by 60 into under root of 2g head on turbine. Question number 98. Specific speed for impulse wheels ranges from option A 0 to 4.5, option B 10 to 100, option C 80 to 200, option D 250 to 300, option E is none of the above. Correct answer is A. Specific speed for impulse wheels range from 0 to 4.5. Question number 99. The ratio of power produced by the turbine to the energy actually supplied by the turbine is equal to option A mechanical efficiency, option B hydraulic efficiency, option C is overall efficiency, option D is turbine efficiency, option E is a relative efficiency. Correct answer is C. It will be overall efficiency. Question number 100. The ratio of actual work available at the turbine to energy imparted to the wheel is called option A. Mechanical efficiency, option B. Hydraulic efficiency, option C is overall efficiency, option D is turbine efficiency, and option E is relative efficiency. So correct answer is A, it will be mechanical efficiency.